let's take a look at how we might stretch a function or compress a function. Okay? I'll call this stretches and compressions. Let's start with the function y equals f of x. Okay? When the function y equals f of x is multiplied by a positive number, I'll call it k, such that k is greater than 1, then the graph of y equals k times f of x vertically stretches the graph by a factor of k. Now, in other words, if you start with a function, we'll say absolute value of x, okay? We want to see what happens to the function, say 2 times the absolute value of x, okay? So my k in this case would be 2. Obviously, there are two different functions, and we want to see how they're related and what the two graphs are going to look like. So let's try to graph those. So let's sketch the graph of absolute value of x, and then we'll graph the absolute value, or 2 times the absolute value of x. Well, we all know what this one looks like. Again, that's one of the library of functions. Let's go ahead and plot a few points on that graph. I'll just plot a few. There's the point 0, 0. We know the point 1, 1 is on the graph. We know the point 2, 2 is on the graph, and maybe minus 1, 1 is on the graph. There's a few points. Okay. Now, I'm going to try to sketch 2 times the absolute value of x. So let's try to investigate what happens. Well, I'm going to go ahead and make a table of values for this function. Okay. We'll call it g of x equals all right. If I plug in a 0, let's start here, maybe in the middle. 2 times the absolute value of 0 is 0. Okay. Maybe we'll put in a 1. Absolute value of 1 is 1. 1 times 2 is 2, so our y value will be 2. Maybe minus 1. Absolute value of negative 1 is positive 1. 1 times 2 is 2. Absolute value of negative 2 is 2. 2 times 2 is 4, and I'll get one more point. Absolute value of 2 is 2. 2 times 2 is 4. All right. So these are going to be corresponding points on our new graph. Okay. Let's sketch them. Negative 2, 4. Negative 1, 2 is right there. 0, 0. 1, 2, and 2, 4. So notice what happened to our function. Here was the absolute value of x. When we multiplied it by 2, all the x values stay the same except the y values get multiplied by 2. And that vertically stretches the graph. Okay? So that's why we call this a stretch. So when I multiply a function by a number that's greater than 1, it's going to stretch the graph. Okay? Now, we could also talk about compressing the graph or flattening the graph out. Now, when will that take place? Well, if we multiply a function by a positive number k such that k is between 0 and 1. K is a fraction between 0 and 1, say a half or a third, a fourth, etc. Then the graph of k times f of x will vertically compress the graph. Okay, let's take a look at what I mean by that. Let's sketch the following two functions. Notice I have x squared in both, but in this function I'm going to multiply x squared by a half. That's going to be my k. We know what x squared looks like, and again I'll plot a few points here. There's the point 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Okay. Now I can go ahead and do a table again, but I don't think I will. Okay. Now let's just think about this. I want to graph this function. Okay. Well, when x is 0, the y value is 0. When x is 1, 1 squared is 1. 1 times a half is a half. So if this is 1 here, maybe a half's out here. When x is 2, 2 squared is 4. 4 times a half is 2. And we can see what's happening to our graph. It's starting to flatten out, or it's being compressed. If I multiplied by this function by a third, it would be compressed a little bit more. If I multiply it by a tenth, it might be flattened out a little more. Okay? So when we multiply by a positive number, if we multiply by a number greater than 1, it's going to stretch the graph. Okay? If I multiply by a number that's less than 1, okay, we're always talking about positive numbers for right now, it's going to flatten the graph or compress the graph. Okay, you might want to try some of your homework problems now, and as always, you can review the lecture as many times as you wish.